Alright, so this is the explanation for our results with the fan cart speeding up to the in a negative direction, or to the left. Uh, what we expected for a fan cart speeding up in a negative direction is for a position time graph is a negative opening, a downwards opening parabola, which we did achieve, although ever so slightly. It still is a downwards opening parabola. For this, we just took the linear fit line, and we got this equation of position equals slope times our time plus our initial position, um, so we can find any position in this time interval. Our slope, or our average velocity, was negative 4.548 inches per second, which was expected since we are going in a negative direction. Our y-intercept, or our position at time equals 0, is a 2.124 inches, meaning that at time equals 0, we are 2.124 inches ahead of our starting point, or origin. Um, this this slope is exactly what we expected, and the shape of the graph is exactly what we expected for a fan cart that's accelerating to the left, or in a negative direction. And let's move on to the velocity graph. All right, so for our velocity graph, we should have gotten a velocity with a linear line, but obviously we didn't get that because nothing's perfect in the world. So for velocity, we got this equation. Velocity equals our slope times our time plus our v naught. Our slope is negative 0.8325 inches per second squared, which is actually our acceleration, meaning that we are accelerating in a negative direction. Our b, or our y-intercept, is negative 2.313 inches per second, which is saying that our time equals 0, our velocity is negative 2.31 inches per second. So our car is already going negative 2.31 inches per second at time equals 0. We took the integral for this graph, which is basically the area underneath the curve, and for a velocity graph, that means the position, the change in your position. So our integral came out to be negative 20.33 inches, which, if we look over here, we start at approximately 0, and we end at approximately 20, which is our change in position as well. So our integral and our position time graph agree, and although we didn't get what we wanted for the velocity graph, it is what it is.